more handhelds too, right? And some of these equipment are very expensive. I will appreciate it when you handle it, do handle with care. Okay? So, first exercise, fm1, which we're going to touch on is profile projector. Alright, as the word profile projector tell you, it means it basically project a profile on the object that you're measuring to a bigger sizes so you can see that clearly and measure that easily. Okay? So this is a typical profile projector, right? We have two models here. Alright, one is the older one, is the newer one. Alright, we are having the same features, exactly the same features. So it's okay to use either one of them. And we have four of them here. Okay, so let me just give you an introduction of this profile projector first. The screen, alright, which will project the object you're measuring over here. The platform where you put the object here, and you can manipulate the object X, Y, X axis, Y axis. Alright, and this is the control panel. Basically, it's the on-off button here. And of course, there's a few more buttons on the switch itself. So first of all, let me go step by step. On-off button is here. Okay, these are the more for the bulb. Now, reminder, when you on off this machine, which is on the bulb, if you happen to make a mistake, do not on it off immediately because you blow the bulb. Okay, so one at a time. If you want to off it later on again, take a few seconds. You blow the bulb. So you turn on the machine, see all the display come up. You need to turn on the bulb. Now these two buttons is the bulb. Hang on. Okay, this is adjust of intensity. Alright, so object. Let me put something there. So I put a coin here as a measurement object. You see the shape of the coin, and I can focus it. I need to focus it. And by the way, there's lenses here. The lens here will determine the degree of the lens will determine how big the object can be blown up. Alright, in our case, somebody is upstairs. It's locked outside. Can you please open for him? So in our case, we are using a multiplied by 10 lens, 10 magnification. That means every object will blow down 10 times bigger. We get 50 with 100, but in our case, 10 is good enough. So the exercise will be using this lens 10. Alright, so for here, now, don't bother to adjust this one. We got 20, got 100, 50, right? 7 to 10. So as I said, it's basically a lens. First of all, you need to set the object you're measuring to focus position. Focus, you see very blurred, right? So by focusing, what you do, you need to move the platform up and down. And to do so, this is the knock you need to use. This is too blurry. Okay? The shape is getting better, right? You can see sharper, right? Okay? So this is the way you project the profile, the shape, and you can measure the dimension and things like that. Alright? But of course, this machine has enough features. You can also see the surface information. Like this case, I on this button here. I turn on intensity. You see? I can see the surface information of the object I'm checking. And I can check from point to point of this dimension. I can measure it. Alright? So this is what you do. Now of course, I mentioned earlier, we have the platform here that allows to manipulate the X axis, Y axis. Okay, so you can see, I move it down, this thing goes Y. Alright, and I can move it X. Okay, why I need to do this, let me explain to you later on. And of course, there's another way to adjust the platform, which is the tilting axis like this. Not the Z, it's tilting axis. Basically what you do is just tilt this guy a little bit for fine adjustment. I'm going to demonstrate to you later on. So, why are we doing this X and Y movement? Okay, the concept of this machine operates on the concept called coordinate measuring method. What it means? If you recall all this, a graph of Y axis and X axis, right? So this is the original point, right? Which is 0 dash 0, isn't it? This one is based X, this is Y, right? So if I have a point here, say, sorry. If I have a point here, say, on the Y axis, this will be example 0, 1, right? Then here will be maybe 2, 0. Alright, here maybe 1, 1. Okay, this is a position. Okay, so if I have an object I place anywhere, say down here, I define this position as reference point. I can tell the height of this object, the width of this object by knowing the distance on the respective axis, isn't it? So this instrument actually using all this concept, coordinate measuring information, knowing the position, then you can calculate the length, the radius, whatever not. All right. So this is the concept. So, are we okay so far?
Yes.
All right. This will be the workpiece will be given to you on the exercise, right? All the objects, again, as I said, look similar, but the dimensions are different by a little bit. Okay, so you choose your workpiece number. There are 4 of them, 1, 2, 3, 4. All right. Very importantly, as I say, you will choose the workpiece number. Let's say number 1. Your report, please do indicate you are working on workpiece number 1 for this exercise FM1. If you're choosing workpiece number 2, write down workpiece number 2. If not, I got no clue what are you referencing. I got no model answer to mark for you. Okay, so I repeat again. Workpiece number for exercise, please take note. Write down the report. Now, so this is the workpiece I'm working on. I shall turn off this one because I don't need the surface information. I only need the profile only. Okay? Now, as I said now, first thing first, to start off the exercise, we have to define the reference point. So in our case, this is the workpiece, the worksheet you need to do. This is the workpiece, and these are the requirements, the parameter label here, A, B, C, D, E, F, G, all the way. You need to measure with this machine. Okay? They are basically linear height, linear length, angle, diameters, alright, radius. These are parameters you need to check. Alright, so I'm going to show you one by one how to do it now. So first thing first, you put in your workpiece for the start. Alright, and I suggest that you put your workpiece on the center of the platform, not at the side or any corner way. Reason being because if you put at the corner, for example here, you got only a little bit of room to move. Center, you got all the maximum movement you can allow you to do that. Okay? So put the center where the beam is shining on. Then you try to focus it. Focus by what? You see this is a short, this is a blurred edge, right? Which means you can't define clearly where's the edge here. Therefore your measurement will be not accurate. So get a focus point by moving the whole platform up and down through tuning these knobs here. See that? This way I get a very fine edge, very clear defined edge. And that will allow me to capture the measurement very accurately. Now second thing, you then position your workpiece this way. Alright, we shall define the very corner of the workpiece here as 0, 0. As a reference point 0, 0. To tell the machine, this is my 0, 0. Where X is 0, Y is 0. Okay? So, my corner point here, this is a display, right? This is Y axis, this is X axis, right? This is 0, 0. Alright? So, first of all, you have to make it perpendicular. Make sure the vertical edge is perpendicular parallel to the Y axis. The horizontal edge is parallel to the X axis. How to do that? I simply move my finger on the object here. Then I'll do a moving down of my object vertically, you see? As I move down, you see this line, the vertical edge, always parallel to my Y axis. See that? Yeah. This one I achieve parallel. Now I try on to the Y axis already. Same thing, I move around, it's parallel, never deviate from my X axis. So in this case I'm okay. If not, you can do a fine adjustment with your finger. Now there's a practice people do that. Before to ensure the object after placed on the original position, you don't move anymore. If not, all your ring will be all up. So what you do, alternative, you can do this way. Place some blue tack behind the object, flatly, so that the object will move away. But I won't think it's necessary. So long you don't touch it, it's okay. Okay, why don't use this one? You can use this one, blue tack, has to stick on it. But sometimes you put too thick, what will happen? The object will be tilted. Therefore, the dimension will be out again when you measure from the top. Okay? So when I do this, do it careful. Or you can put by the side, up to you. Okay? So in my case, I don't need to do that. I don't think I need it because unless you're going to touch it or there's a strong wind blowing it, which is unlikely to. Okay, so first thing, set your workpiece to the original position I just showed you by checking the perpendicular of y axis is. That's done. Alright, move it to the 0 point again. Okay, now I will tell the machine this is my 0 point now. I'll press it 0, 0. Reset the reading of x and y to 0, 0. Okay, I defined that already. Now, there's another information on this machine here, which is the angular. This one, reading the degree, angular. So how is it checked? There's a locking button here. You move this knob here, the whole screen will move in certain angle. You see, as you move around, it tells you the degree. 22 degrees, 56 minutes, and so on and so forth. The other way around also. Okay? So I must tell the machine also that my 0.0 degree is down here, where the two edges together. Alright, this is my 0 point, so I press the 0. It doesn't work. It doesn't allow reset. Never mind, lock it. So just a case, sometimes this button doesn't work. A bit old. Never mind. You
don't use this machine now.
You off this guy. When this is done, off this guy. Again, don't rush to turn it on again. Take a while. Turn on again. Now everything will be 0.
Oh.
Alright, so I tell the machine, this is my angle 0, this is my x0, y0. And I'm ready to do measurement already. Are we okay?
Yeah.
So far? So let me show you how to measure the length, the linear distance, the diameter, center to center, angle and radius. Okay, I'll start with a simple one. The linear distance, for example, m. What's m? M is basically this length.
Yes.
And the object is very small, this length. So how do I know this length? What's the dimension? Quite simple.
Move the
I
X.
simply
Move the
move
X.
my object to this way. From this point, I move around. So as I cross around, see the reading of X reading will shift. Alright, to here, for example, up to this edge here, I see exactly. So when you doing this exercise, please, the person who operating it, make sure your eyes are perpendicular to the screen. Don't stand like this. You know the correct error.
Is in mm or cm?
In mm. Alright, so you see I stretch across and the move a distance of 7.908 mm. Therefore, this is my length of the m. I got my answer. Simple, right? So, if I want to check examples, the height. For example, here to here, B, the B, which is here to the H, the start edge there. Simply, now again I say, when you set up this one, don't touch this anymore. Simply move the y-axis now. I move down to 0. I move down all the way until this one, which is the edge here, touches the origin here. Alright? And this is my distance, 16.079. Ignore the negative sign. Negative sign is okay, we take absolute value. Now, very good question, you see here? The object, by nature, when you machine it, no way can get a sharp edge. See that? No way, right? So how do I know it's running exactly there? How do I know? One way you can do is put a ruler or whatever not. You see? This way. I move it out again. This edge I project must hit here. See that? So from there I conclude this is my point here. Where my B point out there. So the B right now should be exactly 15.859. That's my answer for B. The height. Okay? So with that you can do all the linear measurement easily, no problem.
What about the circle?
Okay, I'm going to show you now. Circle is more challenging, okay? I'm going to show you how to do circle. So there are 3 diameters you need to capture. Alright. First of all, diameter I, the small one. Let me show you. So to measure diameter I, so diameter is how?
会找一个就会找其他的。
This way or this way? It's the same, right? So I do the y-axis, the x-axis first. So what I'll do, I'll project my circle of this diameter I want to capture, touches the axis. In this case, the y-axis. Where it touches means tangent. Tangent, the curve just touch the line here. Alright, then I turn note 1.421. This point is 1.421. Alright, then I go on to move to the other side, tangent the other side. Tangent, 6.460. So my diameter I will be what? 6.460 minus away 1.421 just now. That will be my diameter, isn't it? Or
The one like the outside curve.
yeah, later one by one. So you can also measure this diameter here by what? By the vertical one, right? Similar like you can do the y-axis. Touches the y at the x-axis. 1.466, Alright, then I move down. On the top, 6.456. So my diameter is 6.456 minus away 1.466 now. So this diameter distance should be the same, unless it's not concentrate. Should be the same. You can take either one of them. Easy, right?
Yes.
Are we okay?
Yes.
Now, next thing, more challenging one.
手酸了。
You need to measure center to center of each hole. This is more challenging. Alright, center to center of this hole, how are you going to do it? Somebody will tell me, center, agar lah, put this one center, right? Get the measure reading, right? Then move it to another center, right? I didn't get answer. No, this is not going to be accurate. So I'm going to show you a quick formula, a way to do it. So allow me to show this one. I'm going to put this on the day. So you want to measure the center point, which is L here. Let's look at the exercise L. How to determine L here?
Half of
Half of it, right? How do you know you are exactly the half of it? How do you know?
Divide by 2. Take diameter
Yes.
divide by 2.
So this is the way to do. First of all, you capture x or x1, x or y is okay. Let's say you do x. You get x2. You know what's x2 point, right? You can do that, right? If you know x1 point, right? So because L is what? L be x2 plus x1 divide 2. Because L is in between x1 and x2, correct? So these two lengths plus together divide 2 will be the middle point. Agreed? Agreed, right? So same thing is C. Vertical C. Here to here. How do you know? Basically, if I know y2, I know y1. I'll do y2 plus this length divide 2, I'll give it C. Got it? So, if you know the method to measure to know this length L, can it go on to determine the E here, which is the center of this hole to the center of that hole? Can you do that? You basically do the same thing. Look for E first. Don't look for E. Look for a distance from H to the E here. Then if you know this L,
Oi.
if you know L plus E, you mess away L, you get E, isn't it? So in this exercise, let me teach you a method. To measure all the diameters and all the length to the center of the circle and the center to center point, you just have to capture 12 information. 12 information. Then you go back and go and calculate. Which are the 12 information? Let me show you.
Upload to YouTube.
So
手酸了。
the quicker way to do on this part of the exercise,
18
you do this
minutes.
one, I show you.
到这里不会。
没有 space 哦。
Alright, this is a 3 hole. Okay.
叫你修。
Now, you just have to help yourself measure 12 information, which is x1, x2. You know x1, x2 position, write it down. x3, x4, then x5, x6. Next, you measure another 12 more information, which is
Y1,
y1,
Y2,
y2,
Y3, 4,
4, y5,
Wi-Fi.
Y square.
and y6. Now, once you get this 12 information, you can calculate all the information you need to know.
Y2.com.
Center to center and so on and so forth.
F8.
Let me show you examples. Let's say on the move
Y.
this distance E, which is in your worksheet here. E, which is from where? Here to here. E,
自己trigger
and this is L, right? Alright. So I already show you how to determine L, right? Just now.
Yeah.
To know E, very simple. Same method. You just go back this way. L plus C resistance. To know this resistance is what? Y x4 plus x3 divided by 2, isn't it? Got it? This resistance minus L, you got E, isn't it? So the same thing applied. All the length, here to here, same thing. Alright, same thing here to here, here to here. Am I clear? So, for this exercise, to know all this diameter information, length to length, center to center, this is the way to do. Get the 12 information, 12 of them. You can calculate. So I've covered all of the most of the thing already. The length, the diameter, everything. Now, next thing.
Angle.
Angle, let's do angle first. So there are two angles you need to capture, which is the angle F here, from by this edge here to the vertical one. Okay, so for angle, let me show you.
我又没有学哦，手又没有学哦。
You shall move the object this way. Okay, so where's my angle F here? Remember I told you this line project down, formed by this edge and this vertical, right?
Then you turn the thing.
Yeah.
Until-
Right. So first of all, you
Put
must make
paper.
sure this down here. You use a ruler, or whatever, a paper,
Yeah.
to ensure you are at the point here. Basically, just project down.
Then you
Alright, make sure you hit the 0, 0. If not, you just go down a bit.
叫你啊，靠那么近，
Okay.
搞 gay。
Now, you are ready to capture the angle already. How? I'm going to move the screen
Unlock.
here. So this is my angle F.
哎
Opposite angle the same, right?
哎，
So this is also my angle F, isn't it? So what I do, I'm going to move this edge all the way until it hit here. So the moment I strap, the angle is coming here by this display here. So I'm going to unlock this guy. I'm going to move. Oh, sorry, I'm going to move this one down here, not the other way, this way. Alright, so I'm going to move, see, my Y axis parallel to the slant edge.
still not there yet, Roger.
Yep. Alright, now if you are not sure it's parallel or not, very simple. You just have to move this object up, then join again. You must join perpendicularly, not this way, not that way, but parallelly. How I'm going to do it? I'm going to synchronize my two hands here. X and Y axis here. This way. You hit parallelly, right? If not, you move again. Alright, I check again. They touches together at both ends, you see? Alright, so I confirm this is my angle. I read 49 degree and 15 minutes. That is my angle F. Got it? So I shall now move back this guy to 0, 0.
49.
Alright, I shall show you another angle. Angle P. What's the angle P? By this slant edge again, the horizontal edge here. So angle P over here, I'm going to move it up here.
你的 human bipod 借我一下，
Okay, so this is my angle P.
不要抖哎。
Project from here, this angle here. And we know parallel angle the same, right? This angle the same, isn't it? Parallel angle. So here and here's angle P, isn't it? So what I'll do is simply move my the x-axis now all the way perpendicular to the slant edge. Not perpendicular, parallel to my slant edge. I got my angle P. Okay, so same
不
thing, I
用
unlock
给
this
啦，
guy
我又
and
不是
move.
杂货。
没有。I very uncomfortable. 我
Okay,
没有给到。
so this is my angle P, 44 degrees and 21 minutes.
哎呀，
Answer got it.
我不是杂货，不用给啊。
I put it back.
给你
Okay
给5 minutes，我手酸了。
So with that, we
不要
are
抓我
almost
手。
done. I've said one more thing.
RG.
Yeah, the radius G, not RG. R stands for radius. You ask you to measure this radius curve G. How to do it?
Use hand.
Use what? Use ruler?
Use hand.
No. So, to measure the radius arc here, you need one more thing here. You need this template.
哦，
We're using a comparison technique to determine the radius arc. Okay, this is basically a template being drawn to a scale of 10 because we have an amplifying of 10
我
times.
是吃饱没事
So
做。
every circle, if which is equal to 0.5 mm in
I see
radius,
drawing.
it amplifies by 10 times bigger. That's what I mean.
Oh, so hard.
So first circle is 0.5, second circle is 1 mm, third one is 1.5, forward is 2 mm, so on and so forth.
我数得酸的。
Okay?
我手算了，我拍
Yeah, I'm
25分钟了，我
So what I'm going to do, I'm
run out
going to use
menu
this one to check my radius. I'm going to put my this template onto the screen here. Will this help the clip here?
Oh, convenience.
The clip. I shall adjust such that the vertical edge is parallel to the the x-axis and the horizontal edge is parallel to the x-axis.
Convenience.
Got it?
Ding.
Now I shall use
我手
comparison
酸的，我
techniques.
懂哦，
I will move the object
我
down
懂哦。
onto the circle. I want to compare the curve here with the radius here. You must see the best match,
1、
whereby here or here. So let's see,
3、4、
Is this okay? This is too small, isn't it? Compared to that, it's too small, right? This one, maybe,
6个
maybe. This one, too big, right? So
Six.
definitely this is the right answer, lah.
6 rings. 0.6.
Okay, so what's the curve number? Number 1, number 2, number 3, number 4, number 5, number 6. First, every circle represents by 5. So 6 represents how many?
0.3.
3 mm. 3 mm, not 0.3, 3 mm.
Yeah.
So my answer to radius G is what? 3 mm. Got it? The radius is very small, but big for big.
Yeah, you can. Yeah.
Are we okay?
Yeah.
Anybody got question?
No.
Simple, right?
Super.
So, that's all I have to tell you for FM1. We're done.
Ah, still got other one ah?
FM2.
What, no memory already.
No memory.